Section 4: Severe Winds and Tornadoes. Digging deeper. Downbursts and tornadoes. In the Investigate, you analyze data to determine where most tornadoes occur in the United States. Then, you compared your findings to patterns in thunderstorm frequency to explain the relationship between tornado and thunderstorm distribution. After this, you analyze data to describe changes in the frequency of tornadoes during various times of the year. Finally, you used a model to explore downbursts. Downbursts that affect a relatively small area are known as microbursts. Microbursts cause sudden changes in wind speed and direction, called wind shear. Wind shear can interfere with aircraft flight. Microbursts over short distances are particularly hazardous to aircraft taking off or landing because these winds typically affect only a part of a runway and are difficult to detect. Sometimes people incorrectly attribute wind damage to an unseen tornado when in fact the damage was caused by a downburst. Near the ground, downburst winds blow outward from a central area. On the other hand, winds from a tornado tend to swirl in circles. Microbursts can be deadly. Tornadoes are a threat to people and property mainly because of their very strong winds and powerful updrafts. Winds blowing hundreds of kilometers per hour knock over trees and power poles. They toss automobiles around as if they were toys. They can destroy even well-constructed buildings. Flying glass and splintered lumber cause much of the injury and death associated with tornadoes. In violent tornadoes, the updraft near the center of the system may top 100 miles per hour, or 160 kilometers per hour. This is strong enough to lift a house off its foundation. The most destructive tornadoes are large systems made up of two or more whirling masses of air, or multi-vortex systems. Tornado intensity is rated on the Fujita scale, or F scale. The late Professor T. Theodore Fujita of the University of Chicago devised this scale. The F scale is based on rotational wind speeds estimated from property damage. It classifies tornadoes as weak, strong, or violent. Tornadoes come in a variety of shapes. Some are cylindrical cloud masses with nearly uniform lateral dimensions. Others are long, slender, rope-like pendants. The path of a weak tornado on the ground is typically less than 1 mile long and 330 feet wide. It lasts only 1 to 3 minutes. Wind speeds are less than 110 miles an hour. An intense tornado's path on the ground can exceed 100 miles long and hundreds of meters wide. It has a life expectancy that may exceed 2 hours. Estimated wind speeds in violent tornadoes reach upward of 300 miles per hour. Tornadoes usually track from southwest to northeast. However, any direction is possible. Tornado paths are often erratic. Many cause a hopscotch pattern of destruction. They alternately touch down and lift off the ground. The average forward speed of a tornado is about 30 miles an hour, or 48 kilometers per hour. Winds in most northern hemisphere tornadoes blow in a counterclockwise direction when viewed from above. Strong to violent tornadoes can take place in mountainous areas. Each year, the United States can expect between 700 and 1,100 tornadoes. Of these, only about 1% are rated as violent. Almost 80% of all tornadoes are relatively weak. By late February, the maximum tornado frequency is along the central Gulf states. In April, the maximum frequency shifts to the southeast Atlantic states. In May and June, most tornadoes occur over the southern Great Plains. By early summer, they shift to the northern plains and the Great Lakes region. Tornado development. Most intense tornadoes develop in supercell thunderstorms. A supercell is a single thunderstorm cell that is much larger and longer lasting than an ordinary thunderstorm cell. In supercell thunderstorms, a powerful updraft interacts with horizontal winds. This causes air to rotate about a vertical axis. The rotating air is called a mesocyclone. When viewed from above, the air is rotating counterclockwise. If conditions are right, the mesocirculation narrows. It grows downward toward Earth's surface. As the circulation becomes more narrow, the wind speed increases. The same thing happens when an ice skater performs a spin and brings his or her arms close to their body. Humid air expands and cools as it is drawn inward toward the low-pressure center of the whirling system. Cooling of air causes water vapor to condense into water droplets. The droplets form a funnel-shaped cloud extending downward from the parent cumulonimbus cloud. If the funnel cloud strikes the ground, dust and debris is drawn into its circulation. The system is then described as a tornado. About 25% of mesocyclones produce tornadoes. Most supercell thunderstorms develop as part of a squall line in the warm, humid air ahead of a well-defined cold front. A squall line is an elongated band of thunderstorm cells. A key condition for bringing cold and warm air masses together is a strong cyclone. A cyclone is a stormy weather system that is plotted on a weather map as L, or low, for the relatively low air pressure at its center. Here, cyclone does not refer to a hurricane or a tornado. Instead, it refers to a rather large weather system. In this system, surface winds blow counterclockwise and inward when viewed from above in the northern hemisphere. This system may be large enough to affect the weather over the eastern third of the United States at one time. Surface winds and a cyclone pull together contrasting air masses to form fronts. Severe thunderstorms and tornadoes are most likely in warm, humid air mass located southeast of the center of a cyclone and east of a cold front. Severe thunderstorms and tornadoes have been reported in every state. However, they are most frequent in a north-south belt in the center of the nation. The area stretches from East Texas northward. It passes through Oklahoma, Kansas, Nebraska, and into southeast South Dakota. This area is called Tornado Alley. More tornadoes occur in that region than any other place in the world. There are other belts of relatively high tornado frequency. They stretch from central Iowa eastward to central Indiana. And along the Gulf Coast states. Tornadoes are infrequent infrequent in the Rockies, the Appalachians, and along the West Coast. Why are tornadoes so frequent in the central United States? Here, all the factors needed for development of severe thunderstorms come together. No mountain barriers separate the Canadian prairies and the Gulf of Mexico. That is, nothing prevents cold air masses from surging southeastward from Canada. There is nothing to stop warm, humid air masses from flowing northeastward from the Gulf. Where the two contrasting air masses join, a sharply defined cold front forms. As you read, thunderstorms that can produce tornadoes are most likely to develop in the warm, humid air mass just ahead of the cold front. Although tornadoes have been reported in every month of the year, they are most common in spring and early summer. At that time of year, the temperature contrast in between air masses is greatest, meaning that the potential for severe thunderstorm development is highest. Tornadoes are hard to predict. This is because they are such a small and short-lived system. When conditions in the atmosphere are just right for a severe thunderstorm or tornado to occur, a severe weather watch is issued. It is issued by the National Weather Service's Storm Prediction Center in Norman, Oklahoma. The public is advised to listen to further reports. If a severe thunderstorm or tornado has been detected on radar, the Regional National Weather Service Forecast Office issues a warning. The warning states the locations that might be impacted. People in these areas should take all necessary precautions. Forecasting and monitoring dangerous thunderstorms. The National Weather Service radar uses the Doppler effect. It is used to figure out how air moves within a thunderstorm. It can give the public advance warning of tornadoes. The Doppler effect is named for Johann Christian Doppler. He was the Austrian physicist who first explained the phenomenon in 1842. For this reason, weather radar with the ability to detect velocity is often referred to as a Doppler radar. Recall that the Doppler effect refers to a shift in frequency of sound waves or electromagnetic waves when a source or receiver is moving. For example, the pitch of an ambulance siren sounds higher as the ambulance approaches. The greater the frequency of the sound, the higher the pitch is. The pitch sounds lower as it moves away. The Doppler effect is also used in devices that measure the speeds of cars or a pitched baseball. Doppler radar monitors the speed of precipitation or dust particles as they move directly toward or away from the radar antenna. With this movement, the frequency of the radar signal shifts slightly. It shifts between emission and return. This shift, the Doppler effect, is calibrated by a computer. It is calibrated in terms of the motion of the particle. In this way, forecasters can detect a mesocyclone before it turns into a tornado. Doppler radar displays are color-coded. Greens and blues indicate motion directly toward the radar. Reds and yellows mean motion directly away from the radar. On a Doppler radar image, a tornado vortex signature appears as a small region of quickly changing wind direction within a mesocyclone. A TVS is a signal that a tornado may be forming. Tornado safety tips. If you have been warned that a tornado is approaching, or if you see a funnel cloud, you need to seek shelter. Go to a tornado shelter or a steel-framed or substantially reinforced concrete building. If you are at home, go to the basement. If there is no basement, go to a small room, such as a closet, bathroom, or interior hallway, in the center of the house on the lowest floor. Seek shelter under a mattress or a rigid piece of furniture. Do not go near windows and outside walls, and do not open windows or exterior doors. If you are in an office building or school, go to an interior hallway on the lowest floor or a designated shelter area. Lie flat on the floor with your head covered. If possible, avoid auditoriums, gymnasiums, supermarkets, or other buildings that have wide, free span roofs. Never try to outrun a tornado in a car. Tornadoes move quickly and erratically, so it is hard to anticipate which direction they are going. Instead, stop and seek shelter indoors. If this is not possible, lie flat in a ravine, creek bed, or open ditch that is not flooded. Never seek shelter in a mobile home, car, or other motor vehicle.